Welcome to your factoring boot camp. We are going to do some processes for how to factor different types of polynomials and some examples that you can use to strengthen your factoring. You'll need two different documents that will be kind of going through here to help you. The first one is your part one, that's your factoring summary. It goes through the processes of step by step what to do to factor each, like what to do for each process. And then there's a part two, which is the examples, and we'll go through all of these examples together. So make sure that you have these available for you. And here we go. So we'll start with the first one. The first process that we're going to go through is factoring out the greatest common factor, or GCF, of expressions. This is always going to be your first line of defense. You'll notice if you look through the processes for any of these polynomials, the very first step is factor out a greatest common factor if possible. So this process is your first line of defense no matter what polynomial you're given. The first thing that you're going to do is look to factor out a greatest common factor. So let's just start here with the example in A. We're looking for the greatest common factor. That means the largest quantity that comes out of everything here. So for here, for part A, let's look at our numbers first. 4 and 8. What's the largest number that divides out of both 4 and 8? That's a 4. And we'll also look at our variables. So 4 is going to factor out of both of these. And we'll also look at our variables, x squared and x. What's the largest variable there that factors out of both, that has to divide out of both? That's going to be just an x. So an x squared does not divide x, but x does divide x squared. So that's going to be the biggest one we can do. So you're going to put your greatest common factor outside and start your parentheses. Now what you're going to do is you're going to divide each term here by that greatest common factor of 4x. So when we take our first term here, 4x squared, and divide by our GCF of 4x, 4x squared divided by 4x gives us just an x left over. Again, I will write out what we did to do that. Basically here, you're taking that 4x squared that you had in your original, and you're dividing by your greatest common factor to see what's left. And your 4's will cancel, you get an x left. So that's why there's an x in here inside. And then there's a minus sign here, so we're going to keep that negative. And then we are going to do the same thing here. So you're going to take your second term here, this 8x, and you're going to take that and you're going to divide by your GCF of 4x. So when you take 8x and you divide by that GCF of 4x, you're going to get a 2. So that's what's in here. So we've got 4x times the quantity x minus 2. We've just factored the greatest common factor out of this given expression. This is what your answer will look like. It's going to look like your GCF times a quantity in parentheses. All right, let's try part B here. So we are going to look at the numbers first. 12, 18, and 6. What's the largest number that divides all three? Well, that answer is 6. And now we're going to look at our variables. X to the 4th, x to the 3rd, x squared. What's the largest power of your variable that divides everything? Well, that's x squared, right? That will divide out of everything. And so that is going to be our GCF, 6x squared. So we're going to write our GCF and start our parentheses. And now we're going to take each of our terms here and divide by our GCF. So in here, that's going to be 12x to the 4th divided by our GCF of 6x squared. And when we do that division, what do we have left? Well, we will have 2, because 12 divided by 6 is 2. X to the fourth divided by x squared, we've got an x squared left. And then we'll keep going. We got to take our next term divided by our GCF. So this is going to be 18x to the third divided by that GCF of 6x squared. When we do that division, we are going to get, there's a minus here, 18 divided by 6 is 3. X to the third divided by x squared gives us an x. And so 18x to the third divided by 6x squared is 3x. So that's what we have left in the next step. And finally, we have to go to our last term here, and we're going to do 6x squared divided by our GCF of 6x squared. And when we divide those two, 6 divided by 6 is 1. X squared divided by x squared is also 1. So all we have left in here is plus, oh, sorry, there we go. All we have left in here is, come on, there we go, plus 1. And so we factored out our GCF of 6x squared, and inside this quantity, we have 2x squared minus 3x plus 1. All right, let's try part C here. We are looking for the greatest common factor, the biggest thing that factors out of everything. So we're going to look at our numbers first. -7 and 14. What's the largest number that divides out of both? That's a 7. And look at our variables. We have an x here and no x in the other term. So we can't take an x out of both pieces. So it's just going to be the number part is going to be our GCF here. Now, the other thing here is that this is negative in front of the x here. Generally, if you have a negative in front of that, we call this the leading term, the one with the highest power of x. If you have a negative there, it's generally going to make your life easier to factor the negative out with the number. So let's take out a -7 this time as our GCF. So if we divide a -7 out of everything, we'll write our GCF out front and make our parentheses. And now we're going to divide each term here by our GCF. So the first thing we're going to do is take -7x and divide by -7. Well, the -7's will cancel and we'll have an x left in here. And then we're going to take our next term here, which is 14. 14 divided by -7, that's -2. So technically we have this plus here from this guy. 14 divided by -7 is -2. I'm going to write this as -7 times the quantity x minus 2 to simplify that out. But that negative came from dividing a positive 14 by that -7. That's where this guy came from. And so now we factored out our greatest common factor of -7. And then finally, here in part D, we have to take out the largest thing that divides out of both. So usually we would look at our numbers, and there's a 3 here. There's not a number out front here, so there's not a number that we can take out. And then we'll look at our variables. There's an x here, but not an x on the other side. So there's not going to be an x in our greatest common factor. But do you notice this whole quantity here, this y squared minus 2, this is in both pieces. That means that's a common factor. That is something that both pieces have, and we can factor that whole thing out. So our GCF here is that whole y squared minus 2. So we're going to factor that out of everything. So we'll write that out front, and we'll start our parentheses. Now we're going to take each term, and we're going to divide by our GCF. So here, again, if you're having trouble seeing this, we're going to take our first term here, x times y squared minus 2, and we're going to divide by that GCF of y squared minus 2. Our y squareds minus 2's are going to cancel. And so what we have left when we take out our GCF here is just that x. And in our second piece, we have to do the second one as well. We are going to take our 3 times y squared minus 2 and divide by our GCF of y squared minus 2. And when we do that, we are going to cancel those y squared minus 2's, and we will just have plus 3 left. Notice when you take out those y squared minus 2's, the stuff you have on the outside is what's left. So the x plus 3 that's on the outside, that's what goes here. You'll start to get faster at this the more you practice that. But this is what we look like when we factor out our greatest common factor of y squared minus 2. So that is how we take out a greatest common factor. You're going to look for the largest thing that divides out of all of your terms, factor it out of everything right off the bat, and then after that, we're going to look to see if there's more work to do inside the parentheses. So let's start with our first process here. So again, the first thing that you're going to do is always look to factor out your greatest common factor first. And then look at what's inside your parentheses after you've taken out your greatest common factor. Or if there's no greatest common factor to take out, then you're going to look at what you have. If you have 4 terms in your polynomial, you're going to factor it by grouping. To factor by grouping, you're going to chop it in half. Your polynomial, you'll chop it right in half. You'll group the first 2 terms together and the last 2 terms together. You'll take out the greatest common factor for each of those groups. And then after you do that, you will notice that there is a common factor in both of those groups. And you're going to take out that common factor from the whole thing. And then finally, you can always check your answer by multiplying. So let's try this here. So factor by grouping. Again, we use this when we have 4 terms. And here we've got 1, 2, 3, 4 terms. A term are pieces that are connected by addition or subtraction. So because these are all connected by addition or subtraction, they're terms. We've got 4 terms here, so we know that factoring by grouping is how we want to tackle this. First thing you're going to do is you're going to look to see if there's a greatest common factor that comes out. So you'll look at your numbers. 1, 3, 4, and 12. What's the largest number that divides all of those? Because we have a 1 here, that means a 1's the largest number. And what about the variables? We have an x to the third, an x squared, an x, and then no variable at all here. Because there's no variable here with the 12, that means that there's not a variable that's going to divide out of everything either. Since 1 is the largest thing that divides out of all of these, there's really not a greatest common factor to take out. Dividing everything by 1 is going to give us exactly what we started with. So no greatest common factor here. So now we're going to chop this in half. So I like to just draw a line right here and separate these into 2 pieces. You've got this group here and this group here. You're going to one at a time take the greatest common factor out of each group. So let's look at this left side. X to the third minus 3x squared. What's the greatest common factor over here? Well, the largest thing that comes out of both is 1x squared. And so we're going to go ahead and factor that out of the left side over here. We'll have x squared and start our parentheses. And we're going to take an x squared out of each piece. X to the third divided by x squared, that leaves us with 1x in here, minus 3x squared divided by x squared, leaves us with just a 3. So on this left side, we're going to take that x squared out. We're going to have x squared x squared times x minus 3. And now we're going to do the same thing. We're going to look on this side. And our greatest common factor over here, the biggest thing that comes out of both pieces, is a 4. 4 will divide both 4 and 12. Since the 12 doesn't have an x in there, we won't have a variable. It's just going to be 4. Now, I know I covered it up with this line right here. There's a plus sign that connects these two pieces. So I'm going to go ahead and make sure that my plus sign is here. And then I'm going to take out my greatest common factor of 4 here. And when I do that and take out a 4 out of everything here in this group, I'm going to have 4x divided by 4 leaves me an x, minus 12 divided by 4. 12 divided by 4 is 3. Okay, so now we've grouped this together and taken out the greatest common factor from each group. Notice after we do that, we have a matching factor here. So now, because I have an x minus 3 in both pieces, that is my greatest common factor overall here, and I can factor that out of the whole thing. And so when I do that, I'm going to take an x minus 3 out of each part here. X squared times x minus 3 divided by x minus 3 leaves us with x squared here. And 4 times x minus 3 divided by x minus 3 leaves us with a plus 4 here. So now we are completely factored. Basically, this is what we're going to look like when we're completely factored. We're going to have thing 1 in parentheses times thing 2 in parentheses. And even up here, when we factored out a greatest common factor, we had thing 1, that up here, that was 4x, that was our thing 1, and thing 2 was in parentheses. Our goal with factoring is to get thing 1 times thing 2, and here we are, thing 1 times thing 2, we are factored. And you can always check your factoring to make sure that you've gotten it correct by multiplying this out. To multiply two things that look like this, you're going to FOIL. You're going to multiply the first two. X times x squared is x to the third. That's a 3. You're going to multiply your outsides. X times 4 gives me a positive 4x. You're going to multiply your inside, which is negative 3 times x squared gives us negative 3x squared. And you're going to multiply your last pieces here. Negative 3 times a positive 4 gives us negative 12. Notice that's what we started with, x to the third minus 3x squared plus 4x minus 12. This is exactly what I started with, which means we've done it correctly. You can always do that and check yourself by foiling and multiplying this whole thing out and making sure that you get what you started with. All right, so I want you to pause the video and try to do this second factor by grouping example. So go ahead and pause the video, give that one a go on your own, and we'll come back together when you're ready. All right, let's work through this together. So we've got 4 pieces here. 1, 2, 3, 4. That means we're going to factor by grouping. First line of defense is looking for a greatest common factor. Do I have a number that factors out of everything? 3, 7, 6, 14. Is there a number that divides all of those? No, nothing other than 1. So that's not going to help us. And look at our variables. X to the third, x squared, x, and no x's. Since there's no x in the 14, we aren't going to have a greatest common factor with an x in it. So no greatest common factor other than 1 here. So now we're just going to start grouping. So you're going to chop this in half. You're going to have one group over here and one group over here. Let's start on the left. What's our greatest common factor in the left group here? Well, 3 and 7, the biggest thing that divides both of those is 1. And then we'll look at our variables, x to the third and x squared. The largest thing that divides both of those is x squared. So 1x squared is our greatest common factor over here. And when we take an x squared out, we have 3x plus 7 left in here. And now we'll look at the right grouping here. When we look at the right grouping, we're going to say negative 6, negative 14. What's the largest number that divides both of those? That's a -2. Because both of them have a negative in it, let's go ahead and factor the negative out with the 2. So we'll take a -2 out here and start our parentheses. And there's no x in the 14, so there's no x part of this greatest common factor here on the right. So when we take that -2 out, -6x divided by -2, that is a positive 3x. -14 divided by -2, that gives us a positive 7 here on the right. So we've taken our greatest common factor out of each of our groupings, and notice we have a matching factor here. We can factor that out, and we'll get 3x plus 7 here and start our parentheses. When we take a 3x plus 7 out of this first term, we're going to have an x squared left. And when we take a 3x plus 7 out of the second piece, we're going to have a -2 left. And now we're factored. We've got thing 1 times thing 2. We are fully factored, and here is our answer. Again, to check your answer, you can FOIL this out and make sure it gets us back to where we started. When you do that, you can be sure that this is the correct answer. So that's factoring by grouping. Again, you're going to do that when you have 4 terms connected by addition and subtraction. So what if you don't have 4 terms? What if you have 3 terms? Well, that's called factoring a trinomial. So if you have a trinomial that looks like ax squared plus bx plus c, you've got 1, 2, 3 pieces. Your process is going to differ a little bit based on whether your a value, this number in front of your x squared, is 1, or when it's a number other than 1. When that a value is 1, our process is going to be a little simpler, so we're going to start there. If you have basically, if a is 1, that means your polynomial will look like x squared plus bx plus c. So if you have just an x squared with a 1 in front of it, this is your process. You're going to start by factoring out a greatest common factor if you can. After you do that, you need to find 2 numbers that multiply to c. C is the number here by itself. And those same 2 numbers that multiply to c have to add to this b value, the number in front of your x. And once you find your 2 numbers that multiply to c and add to b at the same time, you're going to put those 2 numbers into a double bubble, which is 2 sets of parentheses with your variable. We'll talk about that in a second to look exactly, so you'll know exactly what I mean by that. But you're basically going to pop those 2 numbers into your double bubble with your variable, and you're done. And then again, you can always check your answer by multiplying it out and foiling to make sure you get back to where you started. Okay, let's practice this process. The first thing that you're going to do is factor a trinomial where your a value is 1. So let's look at what we've got here. We've got x squared minus 10x plus 16. We've got 1, 2, 3 terms, and the number in front of our x squared is a 1. So when this happens, again, first line of defense, we are going to look and see if we have a greatest common factor. Is there anything that divides out of all 3 pieces other than 1? Nope, just a 1 is the biggest thing that divides out of everything. So now we are going to look for 2 numbers. Our 2 numbers need to multiply to our c value, which here is 16. And those same 2 numbers need to add to negative 10. I need 2 numbers that multiply to 16, and those same 2 numbers have to add to negative 10. Anytime if you're struggling with coming up with these, let's just start thinking about numbers that multiply to 16. So 2 numbers that multiply to 16, it could be 16 times 1, but those aren't going to add to 10. Okay, something else that multiplies to 16, maybe 2 times 8. Oh, with 2 plus 8, that gives me 10. I need them to add to negative 10. So to add to negative 10, what if I make them both negative? Negative 8 and negative 2. Negative 8 times negative 2, that's a positive 16. And negative 8 plus negative 2 gives me negative 10. Those are my two numbers, negative 8 and negative 2. Okay, so now that we've found our two numbers, let me come back to this. Once we have our two numbers, we're going to create a double bubble. So here's one bubble and our second bubble. You're going to put each of these numbers into its own bubble with your variable. Our variable here is x, so I'm going to start with my variable x, and I'm going to pop each of my numbers into a bubble with your variable x. And we are factored. We are thing 1 times thing 2. This is, in fact, factored. And to check our work, let's go ahead and multiply it out. So just to make sure we didn't mess it up, we're going to do first x times x is x squared. We'll do outside. X times negative 2 is negative 2x. We'll do inside, which is negative 8x. And we'll do the last, which is positive 16. When we add all these together, we'll combine our like terms here. We've got x squared minus 10x plus 16. That is what we started with, and we nailed it. So that means this is factored. We've got thing 1 times thing 2. This factors into x minus 8 times x minus 2. All right, go ahead and pause this video, work through this example here, and then when you're ready, we'll come back together and hit play. Okay, so let's start working through this together. Your first line of defense, see if there's anything that comes out of everything. So 6, 18, 60, is there a number that divides all three of those? Yes, a 6 will come out of all of those. And then x squared, x, and there's no variable here, which means we're not going to have a variable with this, but a 6 does come out of everything here. So when we take a 6 out, we're going to get x squared minus 18x divided by 6 is 3x, minus 60 divided by 6 is 10. So after we take that greatest common factor out, now we're going to look at the thing in parentheses and see if we can do more work there. So we're going to look at this guy right here. I have three terms, 1, 2, 3, and the number in front of my x squared is a 1. That means we're going to use our double bubble process. So to do that, we are going to look for two numbers that multiply to our C value. Our C value here is negative 10. And those same two numbers have to add to our B value. Our B value here is negative 3. So I'm looking for two numbers that multiply to negative 10, and they have to add to negative 3. If you're having trouble with this, I want you to start by thinking of things that multiply to 10. So things that multiply to 10 are 10 and 1 or 5 and 2. Those are the things that multiply to 10. So we're looking for a combination here that will multiply to negative 10. That means one has to be negative, one has to be positive, and add to negative 3. In order to do that, we're going to have to use these two. And to get a negative 3 when we add them, the 5 is going to have to be negative, and the 2 is going to have to be positive. All right, so now that we have our two numbers, now we can double bubble. So we will do our double bubble, and we're going to put a variable in each one, x, and then put each of our numbers in parentheses with those. X minus 5 times x plus 2. That is the factored form of this guy here. We had a 6 out here. He needs to come along for the ride. Don't forget to include him. Nobody gets left behind. And we are factored. So this thing factors into 6 times x minus 5 times x plus 2. Okay, so what if we have three terms, but our a value is not 1? What if that number in front of our x squared isn't just a 1, and we can't factor out that greatest common factor to get a 1 in front of that x squared? Well, in that case, you're still going to look to factor out a greatest common factor first. And then after that, you're going to find two numbers that multiply to a times c. This is sometimes called the AC method. The reason for that is because you start by multiplying a times c. And you need two numbers that multiply to a times c. And those same two numbers need to add to b. And then once you find those two numbers, we need to split our middle term into two pieces. And I'll show you what that looks like in just a minute. But after you split your middle term into two pieces, you're going to have four terms now instead of just three. And we know how to factor when we have four terms. If you have four terms, you factor by grouping. So the very last step of this, after you split your middle term, is factor what you have left by grouping, and then you'll be factored, and you can always check your answer by multiplying. So let's try this. We have an example here, 2x squared plus 5x minus 3. We've got three pieces, 1, 2, 3. First line of defense is, can I factor out a greatest common factor? 2, 5, and 3. A 1 is the only thing that factors out of that, so there's nothing that I can do here. X squared, x, and no x with the negative 3. I do not have a greatest common factor other than 1. So I'm going to start the AC method. The first thing I'm going to do is take a times c. And again, the a and the c comes from ax squared plus bx plus c. So a is the number in front of my x squared, and c is the number by itself. So a here is 2, and I'm going to multiply that by my c value, which is negative 3. Take the signs with it. So my a times c value is negative 6. So I'm looking for two numbers that are going to multiply to that negative 6, that a times c. And those same two numbers are still going to add to my b value just like before. My b value here is 5. So I need to find two numbers that multiply to negative 6 and add to 5. Hopefully you're getting a little bit better at this process. The two numbers that multiply to negative 6 and add to a positive 5 will have to be positive 6 and negative 1. If I multiply those two numbers, I get negative 6. And if I add those two numbers, I get positive 5. So now that I have my two numbers, we cannot double bubble here, because if our a value is not 1, we have to work a little harder. Double bubble won't work for you here. You're going to have to take your middle term, this 5x, and we're going to split it into two pieces. So everything else stays the same. Our 2x squared stays out front. We're going to change plus 5x into plus 6x minus 1x. Again, using these two numbers to split our middle term into plus 6x minus 1x. And then we still have this minus 3 out here on the end. That has to come with us. So now, once we split our middle term, notice we have 1, 2, 3, 4 terms here. We're going to factor by grouping. To factor by grouping, you're going to cut this thing in half and group each piece on either side. So on the left side, our greatest common factor over here is 2x. When we take a 2x out here, we get x plus 3. And on the right side, our greatest common factor over here is a negative 1. When I take a negative 1 out of everything here, I get x plus 3, because negative 3 divided by negative 1 is a positive 3. And notice I have a matching factor, so I'm going to take that out of everything. I'm going to get x plus 3 times 2x minus 1. And I am fully factored. Thing 1 times thing 2. You can always check your work here with multiplication. And if you FOIL that out, you will notice you get exactly what we started with. So again, I want you to pause the video and work through this example. And then when you're ready, hit play. All right, let's work through this one together. You're going to look for a greatest common factor here. 15, 19, 6. Is there a number that comes out of everything? No, not this time. 19 is prime, which means nothing's going to divide that. Okay, so we're just going to start our AC method now. To do that, we're going to take A times C. Our A value here is 15. Our C value is 6. When I take 15 times 6, I get 90. So I'm looking for two numbers that multiply to a positive 90, and they have to add to our B value here, which is negative 19. So two numbers that multiply to 90 and add to negative 19. Well, to do that, I'm going to need 10 times 9. That multiplies to 90, but I need to add to negative 19, which means if I make both of them negative, they still multiply to positive 19, or sorry, positive 90, but they add to negative 19. Those are my two numbers. And so now I'm going to use those two numbers to split my middle term. So the 15x squared stays, the plus 6 stays, but I use my two numbers here to split my middle term into negative 10x minus 9x. My middle term splits into these two pieces. And then once I do that and I split my middle term, I've got 1, 2, 3, 4 terms. I factor by grouping. Chop it in half, group in front, group in back, and take the GCF out of each one. On the left here, I'm going to take out a 5x as my GCF. When I take out a 5x, I get 3x minus 2. On the right, I'm going to take out a negative 3 for my GCF. And when I do that, I get a positive 3x minus 2. Because a negative 9x divided by negative 3 gives me positive 3x. A positive 6 divided by negative 3 gives me a negative 2. I have a matching factor. Take it out front. 3x minus 2. Start my parentheses. When I take that out of each piece, I get 5x minus 3. I've got thing 1 times thing 2. I am factored. And again, you can always check this with the FOIL process of multiplying it all out. All right, one last factoring method to go through with you, and that is, what if we don't have 4 terms or 3 terms? What if I have 2 terms? Well, if you have 2 terms, then the only thing that you can do with that is either take out a greatest common factor or look to have a difference of squares. So to see if something is a difference of squares, you're going to look to see if it is in the form of a squared minus b squared. If it's something squared minus something else squared. If you are in a difference of squares, something squared minus something else squared, that factors into a plus b times a minus b. So again, this is a difference of squares. The word difference in mathematics means subtraction. This sign between your a squared and your b squared must be subtraction in order to do this method. If it's a squared plus b squared, that's not factorable. You cannot factor that using a difference of squares. This only applies if those two perfect squares are connected by subtraction. In that case, it's a squared minus b squared factors into a plus b times a minus b. And then once we do that, We'll do the double bubbles. The square root of the first term goes in the first spot in both of our bubbles, and the square root of the second term goes in the second spot of each of our bubbles. And you're factored, and you'll check by multiplication. Okay, so let's try this. So in this first one, I have two terms. Okay, two terms. First line of defense is always greatest common factor. Can I take a greatest common factor out of both of these? No, I don't have anything other than 1 to take out, so I'm stuck. I have two terms, which means I'm going to look to see if it's a difference of squares. Do I have something squared minus something else squared? Well, in this case, I do, right? Because first, on the first part, I have x squared. That is something squared. In the second, and I have my minus here, that's good. And the second part, 144, I can write that as something squared. 144 is 12 squared. So I have x squared minus 12 squared. That means my a value here is x, my b value here is 12. So this is, in fact, a difference of squares, and I can factor it with my double bubble. The square root of the first thing, so this x is going to go in our first spot. The square root of the second piece, which is that 12, that's going to go in my second spot. You're going to connect one with addition and subtract, or connect the other with subtraction. So this factors into x plus 12 times x minus 12. This is, in fact, a difference of squares. This is thing 1 times thing 2. We are factored. And I do want to show you the foiling here just to help you out. So to multiply this out and make sure it works, x times x is x squared. Now we'll multiply the outsides together and we get negative 12x. Multiply our insides together and we get plus 12x. And multiply the last together, we get negative 144. So now we are going to combine what combines. We've got x squared, negative 12x plus 12x. That's 0x. These go away. And then we have minus 144 left. That is, in fact, what we started with. This is why a difference of squares works, because when you factor or when you multiply everything out, your middle two terms here will always cancel with a difference of squares, and that's why these guys work. Okay, so that's how factoring a difference of squares works. Give the second one a go, and we'll come back in just a minute. So hit pause and work through that on your own. All right, y'all, let's do this together. We are going to first see if a common factor comes out of everything. 36 and 49. Nope, nothing divides both of those things. So we don't have a common factor here. So now we just have to see, we've got two terms. Is this a difference of squares? Do I have something squared minus something else squared? Well, 36. 36 can be written as 6 squared. That is a square. And then 49x squared, that can be written as 7x squared. That's a 7, sorry. And so I've got 6 squared minus 7x squared. And again, they're connected by subtraction. This is a difference of squares. I can factor this. I'm going to do my double bubble. This goes in the first spot in both of my bubbles. This goes in the first or in the second spot of both of my bubbles. And you're going to connect one with addition, one with subtraction. So 6 plus 7x times 6 minus 7x. Thing 1 times thing 2, we are factored. You can always check that by foiling and making sure that everything multiplies out correctly. All right, those are your factoring processes. Those are what you're going to use to factor. So again, always look to factor out a GCF first. That's the very first thing you're always going to do. From there, you're going to see how many terms you have. If you have 4 terms, you're going to factor by grouping. If you have 3 terms, you are going to find 2 numbers that multiply to something and add to something else. If your number in front of your x squared is a 1, you're going to double bubble with those 2 numbers that you found. If your number in front of your x squared is not 1, then you're going to use your 2 numbers to split your middle terms so that you've got 4 terms and then factor by grouping. And if you had 2 terms from the start, you're going to see if it is in fact a difference of 2 perfect squares. And if it is, then you are going to write it as one thing squared minus another thing squared, and you're going to double bubble with a plus and a minus. All right. And again, you can always factor by grouping. So the hard part here is, what if I don't tell you what method to use? You have to figure that out on your own. So I want you to hit pause. I want you to work as many of these as you can, and we'll come back together. Hit play when you're ready. All right, y'all, let's work on factoring these guys. So we're going to start with part A here. Again, our first line of defense is always going to be to look to factor out a common factor. So does anything divide 4, 28, and 49 all at the same time? Nope, nothing other than 1. So we can't factor any greatest common factor out. And so we're going to have to figure out what to do next. How many terms do we have? 1, 2, 3 terms. And so we're going to factor this as a trinomial. We need to find our 2 numbers that multiply to something and add to something else. But is our leading coefficient, the number in front of our x squared, is it a 1 or is it something that's not 1? 4 is not 1, so we're going to have to work a little harder. So the very first thing we're going to do is start with A times C. Our A value here is 4, and our C value is 49. So we are going to do 4 times 49, and we are going to get 196. That means we need to find 2 numbers that are going to multiply to 196 and add to our middle term, our middle B here, which is negative 28. So I got to find 2 numbers that multiply to 196 and add to negative 28. Sometimes these can be hard to find, so we're going to start listing out things that multiply to 196. You can use your calculator to do this. So I know that 196 times 1 is going to give me 196, but those aren't going to add to 28. So I'm going to go to my calculator. I'm going to divide by 2. So that means 196 divided by 2 is 98. That means 98 times 2 is 196. I'm not going to get those to add to 28, so I'm going to keep on going. The next thing, let's see, 196, can I divide by 3? Nope. 196 divided by 4. I have 4 and 49. 4 times 49 is 196, but those are not going to add to negative 28. I'm going to keep going. 196 divided by 6 does not work. I knew a 5 wouldn't come out, so I didn't bother with that one. A 7 is going to work. I divided by 7, and I got 28 times 7 gives me 196, but those aren't going to add to 28, so I'm going to keep going. 196 divided by 9 doesn't work. How about 196 divided by 8? Nope, that doesn't work. How about a 12? 196 divided by 14. This is 14 and 14. And again, just practice. You can just keep dividing by numbers, working your way up until you find some of these guys. So 14 times 14 is 196. Oh, and I can get negative 28 from these guys. What if they're both negative? we found our two numbers that are going to multiply to 196 and add to negative 28. Sometimes these numbers are hard to find. Use your calculator to help you, and through division, you can start listing multiples. You will find them. You just have to keep working through that, stay persistent. So we found our two numbers that are going to multiply to 196 and add to negative 28. Because our a value is not 1, what we're going to do with those two numbers is split our middle term. So we're going to leave our 4x squared and our plus 49. And then we are going to split this negative 28x into minus 14x minus 14x. And once I've split my middle term, now I have 1, 2, 3, 4 terms. I'm going to cut this in half, and I'm going to factor by grouping. So over here on the left side, the biggest thing that comes out of everything is a 2x. And when I take out a 2x, I get 2x minus 7. And on the right side, I can take out a negative 7. Again, I'm going to take the negative out just because the thing in front of my x is negative. I'm going to take it out. It makes our life a lot easier. So if I take a negative 7 out, negative 14x divided by negative 7 is a positive 2x. Positive 49 divided by negative 7 is negative 7. And I have a matching factor here, so I'm going to factor that out front and take it out of both pieces. When I do that, I have a 2x left from the first piece, a minus 7 left from the next piece, and I have this factored as 2x minus 7 times 2x minus 7. You'll notice these factors match. You can leave it like this, or you can write it as the quantity 2x minus 7, that quantity squared. And we are factored. All right, let's hop to the next one. 5x to the third plus 4x squared minus 15x minus 12. You're going to look for a greatest common factor to come out of everything, and you're not going to find it. So now we're going to say, okay, I've got 1, 2, 3, 4 terms. That means grouping. Chop it in half and take your greatest common factor from each side. On the left side here, the biggest thing I can take out is an x squared. And when I do that, I have 5x plus 4. On the right side, the biggest thing that I can take out is a negative 3. When I do that, I'm going to get 5x plus 4. And I have a matching factor that I'm going to factor out front, 5x plus 4. And I'm going to take it out of everything here. Out of the first one, I have an x squared left. Out of the second piece, I have a minus 3. And I'm factored. You can always look to make sure you're fully factored. Because I have two pieces here, and my first one is a perfect square, and they're connected by subtraction, always look to see if that is a difference of squares, because if this is a difference of squares, you can keep going and keep factoring. But 3 is not a perfect square, so unfortunately, we can't keep going. But I just wanted to kind of point that out, that as you get better at this and you start seeing these a little more, I want your brain to say x squared minus something. Is that a difference of squares? Should I factor that? Here we don't have a difference of squares, so we are all done, and that's the end of the line. All right, number C. We are going to first see if a greatest common factor comes out. And we have one here. We can take a 6 out of everything. So when we take a 6 out, we're going to get 4 minus x squared. And then look at the thing in parentheses. I've got two pieces here, and it is, in fact, a difference of squares, because inside this parentheses, I've got 4, that is 2 squared, and x squared, that's x squared. And I've got something squared minus something else squared. This is a difference of squares. So I can factor this. I'm going to do a double bubble. Again, the 6 comes along for the ride. Don't forget him. Nobody gets left behind. This thing goes in the first part of our double bubbles. this guy goes in the second part of our double bubbles, you'll connect one by addition, the other by subtraction, and we're fully factored. All right, D. Again, first line of defense is the greatest common factor. What comes out of everything here? We can take out a 2 from everything. That's the biggest number that comes out. And an x to the third comes out of everything. So I have a 2x to the third that I can factor out of all of this. And when I do that, we are going to get 2x squared plus 13x plus 6. Okay. And again, look at what's in parentheses. Make sure that we see if there's anything else that we can do. Inside our parentheses, we've got 1, 2, 3 pieces. This is a trinomial. And the number in front of our x squared is not a 1. That means we're going to be doing the AC method. So the first thing we're going to do is take A times C. Our A value here is 2, our C value is 6, and that is a 12. So I'm looking for two numbers that multiply to 12, and those same two numbers need to add to my B value here, which is 13. What are two numbers that multiply to 12 and add to 13? Positive 12 and positive 1. Because A is not 1 here, I'm going to use those two numbers to split my middle term. Again, nobody gets left behind, so 2x to the third is still here. And then when I split my middle term, my 2x squared stays, my plus 6 stays, and I'm going to use those two numbers that I found, my plus 12 and my plus 1, to split my middle term, which is that 13x, into plus 12x plus 1x. And now inside the parentheses, I've got 4 terms. We're going to chop this in half and factor by grouping. So 2x to the third comes along for the ride. Over here, I can take out a 2x, and I will have x plus 6. On the right, the biggest thing I have is a 1 that comes out of everything, so that's going to be x plus 6 over here. I have a matching factor, so I'm going to take that out. Don't forget our 2x to the third. I'm going to factor this x plus 6 out of everything in here, and when I do that, I get 2x plus 1. And now we are fully factored. 2x to the third times x plus 6 times 2x plus 1. All right, E, first line of defense. Does anything come out of everything? Do we have a greatest common factor other than 1? Nope, not in this problem. So we have 1, 2, 3 terms. So we're going to look for two numbers that multiply to something and add to something else. And our A value is 1 here, which means our lives are going to be a lot easier. We're looking for two things that multiply to our C value. Our C value here is negative 12. And those same two numbers need to add to our B value, which here is 4. So I'm looking for two numbers that multiply to negative 12 and add to positive 4. Those two numbers are going to be 6 and 2, right? And then to add to 4, I'm going to need a positive 6 and a negative 2 to make sure that I get a positive 4 out of there. All right, those are our two numbers. Since A is 1, we can just double bubble this. And so we are going to put our variable in the first spot and each of our numbers in the second spot, and we are factored. All right, F. Do we have a common factor? Nope. How many terms do we have? 4. So that means grouping. We're going to cut this in half, and we're going to take the greatest common factor out of each group. In this left group, I'm going to take out an x squared, and I'm going to get x plus 2
In my right group, I can take out a -9. And when I do that, I get positive x plus 2. And I have a matching term, so I'm going to take that out front. And when I take an x plus 2 out of everything here, I get an x squared here and a -9 here. Take a look at what we have before we kind of put a box around this and move on with our lives. I have an x squared and I have a minus. That's making my brain say, is that a difference of squares? And this time it is a difference of squares because x squared is something squared and 9 is 3 squared. And they're connected by subtraction. This is a difference of squares. I'm not done yet in this problem. We got to go all the way to the end. And so I'm going to have x plus 2 here because nobody gets left behind. My difference of squares, we're going to double bubble that. This first part goes in the first piece. The second part goes in the second piece. I'm going to connect one by addition, one by subtraction. And now we are fully factored. Okay, G. We have x squared plus x plus 12. Do I have a greatest common factor? Nope, not this time. How many terms do I have? I've got 3. So I'm going to find 2 numbers that multiply to something and add to something else. My leading term here, what's in front of the x squared? It's a 1. So our lives are going to be easier. We're in double bubble mode. So we have to find 2 things that are going to multiply to positive 12 and add to our b value, which is 1. Okay, sometimes these guys can be hard to find. Let's think about the things that multiply to 12. 12 is 12 times 1. It's 6 times 2. It's 3 times 4. Those are all the things that multiply to 12. I need 2 things that multiply to positive 12 and add to positive 1. Now, you are going to be tempted to use 4 and 3 here, right? Because positive 4 and negative 3 add to positive 1. But what do you notice about that? Positive 4 times negative 3 multiplies to negative 12. I need them to multiply to positive 12. So these guys aren't going to work here. But there's no other way to get a positive 1 out of any of these factors, which means there aren't 2 numbers that multiply to positive 12 and add to positive 1 at the same time. What that means is that x squared plus x plus 12 is not factorable. We call that a prime polynomial. So you can either write not factorable or prime. Um, this, you can't factor this. We're stuck. Okay. So you can't always factor everything, and that's okay. But you should check and go through your factors just to make sure. All right, last one. X squared plus 64. Do I have a greatest common factor? Nope. How many terms do I have? 2. And my guess is that you've noticed, just because of our practicing here, you've probably noticed that this is x squared plus 8 squared. You've probably already started to say, hey, 64 is a perfect square. I'm going to write that as x squared or 8 squared. And you're going to be tempted to factor this as a difference of squares. But again, what does the word difference mean in mathematics? It means subtraction. These are connected by addition. This is a sum of squares. We cannot factor a sum of squares like we can factor a difference of squares. This one is not factorable. Again, you can write not factorable or you can write prime. Either one of these, they both kind of mean the same thing. So we can't factor everything. A sum of squares is not factorable. It's a prime polynomial. All right, y'all, that finishes up our boot camp and our examples. I hope this has been helpful for you. Have a great day.